Thanks Jen for the introduction. My name is Amy Bell and I'm here today to talk to you about our preliminary results so far with the sheep dentition work we've done. This is done with the young sheep on our site here in the New England. And we've got some interesting results that I'd like to share with you today, but just as a quick introduction as to the format of this talk, is I'm just going to be looking at why we're looking at young sheep dentition, how we looked at it, what the measurements were, and just I'll present some interesting results hopefully, and then where are we going to next with this work. So as Jen mentioned, young sheep dentition is important for a whole range of reasons, but one of the main reasons is that it does help make marketing decisions. An animal that is classified as a lamb has a different value to an animal that is no longer classified as a lamb. So it's important to be able to measure some of these things and have an estimate of when these things can change in an animal's life. And we can do that by having a look at the pattern of change in a young animal's life. There was also a recent change in the definition of dentition and how these things are described in industry. So the definition changed from an animal with 0 permanent incisor teeth to now an animal that's under 12 months of age or has no permanent incisor teeth in wear. There can be a big difference in terms of the age of the animal when these traits are apparent. So it was important for us to be able to have an estimate of the variability that we see so that we can make some estimates and put some numbers around the differences that we can see with these with the new definition. And the other question we were asking was, does young sheep dentition actually give us an indication, for example, of something like maturity? And we were able to look at the conception rates through litter size scanned with our ewes in the MLP flock here, and just to see were there some trends evident there that we could estimate. So just moving on to the how do we measure the dentition? So when I'm talking about the young sheep dentition here, I'm specifically talking about our 2017 and 2018 drops here on the New England site. The initial results I'll talk about are looking at all progeny across both years, that being the wethers and the ewes. Now to do the actual scoring, it was a 1 to 5 system we used to talk about the different categories that we found were evident with the sheep dentition. So as you can see there on the slide, the descriptions are a score 1 through to a score 5, with 1 being lamb's teeth only obvious, through to score 5 where there was at least 1 permanent incisor in wear. So there's a range of categories in there as well, but the information that we were particularly interested in was what was the age of the animals in days that we saw these differences in the teeth scores. The animals were checked every 2 to 4 weeks. They were probably checked more frequently as soon as we saw signs of those lamb's teeth being lost. So just a couple of interesting observations we made as we're going through the dentition scoring. In the 2017 drop females, we did see that at mating, which was conducted around 19 months of age, that there was still 1.5%, or 11 ewes, were still showing lamb's teeth only. And at the same time, there was still 7.5% of those ewes were technically lambs under the new definition in that they had no permanent incisors in wear. We also had 1 ewe that went all the way through to scanning in June, where she was still showing lamb's teeth, and she was around 21 months of age at the time. In the 2018 drop ewes, we saw a very similar pattern. They were mated in April as 19 months of age, and we saw just under 3% of these ewes were still showing lamb's teeth only. Similarly, 7.5% of these young sheep were still lambs under the new definition. And again, we had 1 ewe that went all the way through to scanning, having lamb's teeth only. So the graph I'm going to talk to now it's just a frequency distribution to show you the average age at which the animals were scored as a teeth score 5, where they had at least 1 permanent incisor in wear. So this is just a frequency distribution. So as you can see there on the bottom of the graph is just the average age of the animals in days. And I've broken that down into about 10-day increments to try and to tease apart how some of these differences were observed. On the left-hand side of the graph, we have just a physical count of the sheep. So as you can see there, it's a relatively normal distribution. There's a positive skew out to the right-hand side there. But in terms of the average days in age when these sheep changed, their dentition changed to a score 5. For the wethers, on average, they were 508 days, and for the ewes, on average, they were 11 days later at 519 days. The other interesting observation we made, because this scoring category went from 1 through to 5, we actually had a look at the days it took for the lambs to change from a score 2, when they were starting to lose their lamb's teeth, right through to a score 5. And for most sheep, that was around 34 days. And that was typical of what we had seen reported in literature as well. That was around 30 to 35 days. But the interesting thing to note was that we actually had animals that their range in days when they went from a score 2 to a score 5, was anything from 10 days right through to 125 days. So a very big variation in terms of how long those animals took to go from a score 2 to a score 5. But again, that can have a big impact on the number of animals that are in certain lamb categories. Just moving on now to some of the actual analysis that I did as part of this work. And again, this is preliminary analysis. I've decided to only focus on the ewe progeny at this point in time for both the 2017 and the 2018 drops here. And we also looked at the scanning results from their first lambing opportunity, which was again conducted when they were about 19 months of age. And the trait that I was looking at there was litter size scanned, or the number of fetus that we were able to see with the scanning results. So one of the questions, and I've mentioned this in my earlier slides, was we're keen to see if the age they were when that dentition changed, did that have an effect on conception, for example, and we measured that by the number of lambs that were scanned. Just by way of a bit of background, the ewes were joined for 2 cycles or 2 opportunities with the ram when their average age was around 19 months or 580 days, just to put that back into context of when things were going on with their dentition changes. I looked at a range of effects for significance, including the more typical ones. Dam source is something that's probably unique just to the site here, and that just reflects the foundation ewes that generated the 2017 and 2018 drop progeny. We also looked at year of birth, birth type and rare type, and also fitted effects of pre-mating body weight, pre-mating condition score, hogget fat and hogget eye muscle depth. We did actually see some pretty interesting results, and I'll talk you through those now. So what I've got here is a graph of the pre-mating body weight and the average age in days the progeny were when their teeth were in wear. So as you can see there, we have a very big range in body weights, but it also matches up. We have a big range in the average age in days when the teeth were in wear. So for example, I've just drawn a little couple of ovals there around some of the sires. For example, sire 23, 17, 21 and number 2. And again, this information is purely worked on sire number. There's no identification to particular sires here. It's just these are the numbers we use to identify the sires within analysis. Even though they all had very similar average days in age when their progeny had at least one permanent incisor in wear, there was a big range in the pre-mating body weight of the progeny. For example, ram 23, his progeny were around 42.5 kilos. Right up to ram number 2 identified there, whose progeny were around 50.5 kilos. So an 8 kilo difference at least across some of these sires in terms of pre-mating body weights, even though they had very similar average age when their progeny were dentition changed to a 5. There is an interesting sire here too, sire number 20, and I'll talk more about him going forwards. But I just want you to note from this slide that looking at the average days in age when their teeth changed, he was further out to the right, which means his progeny were on average older, up to about 555 days on average there. But he was also one of the heavier body weight sires as well, not the heaviest, but he's certainly in the top 5. And as I said, pre-mating body weight had the biggest effect on litter size scanned. And moving on from that, when I plot out now the litter size scanned against the average days in age when teeth were in wear, you can see there is still quite a degree of variation there. The trend is obvious, but it's not actually significant. So this is merely me trying to demonstrate the variation that we saw. And just another interesting observation where we can see there with sire number 20, again, his litter size scanned was slightly lower than some of the other sires. And there may be a suggestion there that looking at the age and dentition as well, there could have been a suggestion that some of those ewes may not have been cycling at that point, which may indicate why the litter size scanned was lower, but it's just an interesting result that we will certainly follow through, and I'll be very keen to follow him through in subsequent joinings as well. So just wrapping up and looking at where we're going to go to next with this work. So we're certainly going to do some further analysis. As I said, these are quite preliminary results, and we have quite a big data set that it's quite exciting to be able to work with data of this quality and quantity. So we're certainly going to have a closer look at the wethers and looking at their fat and muscle traits and how dentition does or doesn't relate to some of that information. Also going to follow through some of the progeny now and have a look at what happened post-scanning and just seeing what actually happened to, for example, the number of lambs weaned from the 2017 drop, because those lambs are certainly well weaned and they're now in their second lambing opportunity. We're going to again have a look at the number of lambs scanned the second time around when the ewes are at their second lambing opportunity. And that's, for example, that's where I'm quite keen to see how sire number 20, if there's a difference from year to year. And we're certainly going to follow on the reproductive information through the life of the project and just relate that back and just see if there's any interesting trends we can observe in terms of dentition. So in summary, there was no clear indication that dentition is a great indication of maturity. There were certainly some interesting observations and there's some interesting trends there that I certainly look forward to doing some more work with in future. To finish off, I would just like to acknowledge the great technical support we have on this project, and I especially want to thank Duncan Elks and Graham Acton for their many, many hours of looking in sheep's mouths and giving us the scores that we have to enable us to do the analysis.